Okay, so good morning. And today we are going to discuss about the concept of subnetting. In our last lecture, we have discussed about LAN and WAN IP addresses. In LAN and WAN, we have discussed if computers are connected with each other with same network ID, then it is LAN. If two different networks are connected with each other with different network ID, then it is WAN. But one problem was there. If we have used one network ID in our network, for example, we have used same network ID like 10.0.0.1, 10.0.0.2, 10.0.0.3 with same subnet mask 10.0.0.1, 10.0.0.2, 10.0.0.3. Okay, and the subnet mask for all the three PC is 255.0.0.0. And if they are connected with each other, this is LAN. Now this switch is connected with the router. Router is also associated with 10.0.0.4. But in A class, we have 16 million IP address. And if router is placed there, then router is a device which works on a different network ID. So if we have to connect another switch with this, okay, another switch with this, then what to do? We are not able to use same network ID in another network because router use a different network ID. Okay. So if I'm not able to use that network in another network, then my IP address should be waste. Okay. Then it will be wastage. So to avoid the wastage of IP address, we use the concept of subnetting. Okay, we don't want to waste our IP address. Subnetting, and in subnetting, we divide the large network into small subnetworks. So we have to divide our one network into another network IDs. Okay, like we have one plot. For example, this is a plot. So I have divided this plot into two parts. Now I have two plots. Okay, but the size of plot is decreased. I can divide it into 4 parts. I can divide it into 8 parts. Okay, I can divide it into 16 parts. It's up to us how many network you want to divide. Okay, so to avoid the wastage of IP address, we are using subnetting, and in subnetting, we have to divide the large network into small network. What is exactly we are going to do? We are going to change our fixed length subnet mask, like this subnet mask. These are already fixed. We have to change these fixed length subnet mask into VLSM, variable length subnet mask. Okay, variable length subnet mask means, because we know that these are the fixed bits 8, 16, 24. For example, I am using 24 bits like this 1, 2, 3, 4, 5, 6, 7, 8 1, 2, 3, 4, 5, 6, 7, 8 1, 2, 3, 4, 5, 6, 7, 8 1, 2, 3, 4, 5, 6, 7, 8. Okay, done. So this is 24 bits because after binary to decimal we are going to change this. Now in VLSM we can change our host bit also, like 1. If 1 should be added there, then it is 25, 26, 27. Why we change this value 0 to 1? Because we know that 1 bit represents network ID and 0 bit represents host ID. Okay, so if 0 bit represent host ID and 1 is added there, now in 8 0 bits, we have 2 raised to power 8 IP. In 5 0 bits, we have 2 raised to power 5 IP. So let's start first with FLSM topic, because in subnetting, first we need to know about the steps. starting. So I'm starting from C class, and I'm taking address 192.168.1.0. So we know that in C class we have how many bits are on? 24. Because in A class 8 bit are on. In B class 16 bits are on. Yes, and in C class we have 24 bits are on. Okay, so in C class we have /24. Okay, now we have to check the steps. First step is find VLSM. What is my variable length subnet mask? Now we know that this is FLSM, but we have to solve it like VLSM. Second step is find magic value. Third step is find block size. Fourth step is number of networks. And fifth step is the number of hosts. Now, after number of hosts, we have one more command like valid host. Valid host means valid IPs. So we have to solve these 6 things. Okay. 24 means, what is the meaning of 24? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 16, 17, 18, 19, 20, 21, 22, 23, 24, 5, 6, 7, 8, 9, 30, 31, 32. So 24 ones are there. Okay. If 24 ones are there, then what is the VLSM? What is the value of 255.5.0? Why? Because we solve it like 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 4, 5, 6, 7. In this, every value is 0. Okay, let's move back to the point. So if we don't consider fixed bit, because in VLSM we considered bits 8, 16, and 24. If we are not considering this, then the value came with us 0. So 0 is your magic value. We don't have to configure this, like we don't have to see fixed bits. So the value that comes here, that is your magic value. After magic value, the formula of block size is 256 minus magic value. 256 minus 0 is equal to 256. Number of network formula is 2 raised to power n. N means on bits. How many on bits are there? 24. And how many off bit are there? 8. Okay. But we don't have to consider /8, 16, and 24. Like, because these are the fixed bit. So we don't have to watch this. Now, from magic value part, we have to check how many bits are on, how many bits are off. There is no on bit there. 2 raised to power 0 is equal to 1. So 8 zeros are there. So host value is 2 raised to power h, 2 raised to power 8. So this is 256. So valid hosts are 256 minus 2. This is the formula, 254. These are the steps used in subnetting. Now, what we need to find.
Sir.
Yes, Dario.
Can you repeat the number of networks, please?
Yes, number of networks are, like, we know that we have number of on bits are 24. But in A class, 8 bit are fixed, 16 bit are fixed in B class, 24 bits are fixed in C class. Because we are finding VLSM, so we don't have to consider this. We have to check how many bits manually we have on. So we have not like on any bit in this, because this is by default value. So we have not on value, so on bits are 0. 8 zeros are there, so 8 are the host bits are there. So network bits are not available in magic value. We don't have to consider. Like, basically, if you ask, we can say 2 raised to power 24 on bits, 2 raised to power 8 are my host bits. Okay, but we don't have to consider fixed bits. So 2 raised to power 0 is my number of network. Okay, you will get the answer, because in this concept we have to find a network ID, my first valid IP address, my last valid IP address, my broadcast ID. Like we have to check from where it can be started. So my network ID is by default 192.168.1.0. Now, first valid IP is 192.168.1.1 because this is the fixed part 192.168.1. In our C class, we have discussed 192.168.1 dot any IP 255.255.255.0. This is my network ID. This is my host ID. So 192.168.1.1 is my first IP. 192.168.1.254 is my last IP. This is my broadcast ID. Like in C class, by default 24, if you are starting from 1.0, so maximum range of your IP is up to 255. So 0 is your network ID and 255 is your broadcast ID. That's why valid hosts are 1 to 254. Understand the mathematical equation?
Yes, yes, yes.
Okay. No issues. If you don't understand, then we have another option. We will manually change the bits there, like in 24. But rest of the session is recorded. So after that, you can easily watch this. So what I'm going to do, I'm going to rephrase this. Okay. Now I'm going to use 25 instead of 24 because we know that 8/8/16 and /24. These are the fixed bit FLSM. Now we have manually changed the subnet mask 25. So what is the value of 25? We have to check 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now one bit is on. Why? Because total 25 is there. 24, 25, 26, 27, 28, 29, 30, 31, 32. This is my like value. Now what will be the VLSM? How to find the VLSM? We find the VLSM like this. 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, and so on, 3, 4, 5, 6, 7. Similarly, we have to find 0 multiplied 2 raised to power 0, 0 multiplied 2 raised to power 1, 0 multiplied 2 raised to power 2. So 2 raised to power 3, 2 raised to power 4, 2 raised to power 5, 2 raised to power 6, 1 multiplied 2 raised to power 7. This is the criteria to find binary to decimal. Okay. So my subnet mask should be 255, 255, 255, 128. Understand this?
Yes, 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 sir.
Yes. So one bit manually we have on. Manually we have on one bit. So magic value is now 128. Okay. So block size formula remains same. 256 minus magic value is equal to 256 minus 128. So now my block size is 128. 128 is my block size. Number of networks. So 8, 16, 24, these are like fixed bits. So 2 raised to power n. Now, how many ones are there? How many zeros are there? 7 0 means 7 host bit. 1 is there. So network bit is 2 raised to power 1. We have on 1 bit network. Now, if we use this subnet mask, then my networks will be 2. And in each network, we have host 2 raised to power 7, like 128. And valid host 128 minus 2 is equal to 126 in 2 network. Wait, I will show you. Like, first we have used, for example, this classroom. This is my classroom. In this classroom, I have 256 students. But due to any conditions, our college authority or our company authority changed this classroom into 2 classrooms. Now 256 are divided into 2 parts. 128 are there, 128 students are there. Divide one large network into 2 parts. So if we use this subnet mask, then this will be the answer. Okay, now we have to find network ID, first valid IP, network ID, first IP, last IP, broadcast ID. Network ID is our very first IP address. Broadcast ID is our last IP address. Okay. Now we have 2 networks. Okay, how to write it? Just write 192.168.1.0 is my first network ID. And what is my block size? 128. So 192.168.1.128 is my second network. Okay. Now we have divided this network into 2 parts. One is 1.0, one is 1.128. So my first IP of my first network is 192.168.1.1, 192.168.1.126, and broadcast ID is 192.168.1.127. Why 127 up to 127? The reason is in one network only we have maximum 128 hosts only. Like 0, 1, 2, 3, 4, 5, 6 up to 127. So the next network starts from 128, 192.168.1.129, 192.168.1.254, and the last IP is 255. So we have divided 0 to 255 into 2 networks. Do you understand this now?
Yes.
Yes. Now you can use these 2 networks into WAN also. Wide area network, you can use this. Okay, you can use this as in WAN. Wait, yes. Now I'm going to solve one more example. Okay, I'm going to solve 26 here. So I'm going to change value here. So if I'm using 26 here, and one more thing I want to say, like if we are using A class, B class, C class, now these values are classless. 26 is a classless value. Classless means like because 8, 16 and 24 are there. Now, for example, you are using 26 here with C class. Then you have to solve it like this. If you are using same addresses with 10.0.0/26, even in class A, if there is 26 is there, you have to solve this like this subnet mask. Okay, I will explain you in /27. Okay, first I am going to change 26. So 26 is 8, 16, 24 ones, 25 and 26 is there. So in VLSM, 2 raised to power 7 plus 2 raised to power 6, like 128 plus 64. So subnet mask is 192. 192. 192. So 256 minus 192 is 64. Now, 2 networks are on, 2 bits are on. So 2 raised to power 2. 2 raised to power 2 is equal to 4. Now 6 bits are off. 2 raised to power 6 is 64. So 64 minus 2. One is network ID, one is broadcast ID. Valid IPs are 62. Now we have divided 256 into 4 parts. Like first network is 192.168.1.0. Second network will be 192.168.1.64. Third network is 192.168.28. And fourth network is 192.168.1.192. Now how I have divided it? Wait. Control X. I'm just dividing .1.193 X. Wait. 192. 192.168.1.65 is my first IP. Like this. Now 192.168.1.62. 192.168.1.63 and 192.168.1.190, 192.168.1.191. Like we have divided like this: 0, 64, 128, 192. I have divided 256 into 4 parts: 0 to 63, 64 to 127, 128 to 191 and 192. Now these are the 4 different networks that can be used in subnetting. Do you now understand the concept of subnetting?
Clear, sir. Very clear.
Yes, that's good. Okay, now what I wanted to let you know about. Now, for example, you are using here A class, any A class 10.0.0.0. Now you don't have to confuse like you are using C class or A class. Now this is a classless value. So you have to like solve this according to your bits. Like 27 is there. If you are using 27 there, then 8, 16, 24, 25, 26, and 27. I know that in A class 8 bits are on, but that is minimum criteria. 27 can be there. So 255, 255, 255, 224 is there. Subnet mask. So if 224 is your magic value, then 224 is equal to 32. Now, how many bits are on? Now, if we are watching according to the A class, then we have on the bit 8, 16, and 17, 18, 19. Okay. So 2 raised to power 19 are the on bits. But we have to divide it like easy purpose. So we have to see 24 is known as fixed bit. So after 24, how many bits are on? Only 3. So we have to solve it like only 3 bits are on. Okay, for example, like 20, I will solve you for the 23. If 23 will be there, for example, 0 will be there, then you have to say 2 raised to power 7 is your on bits. So you don't have to confuse in this value. You have to solve this with /27. So 3 bits are on, then 2 raised to power 3 is equal to 8. 5 bits are off because 5 zeros are there, 32. And 32 minus 2 is equal to 30. So like 256 are divided into 8 parts. So what will be my network ID? Like 10.0.0.0. What is my block size? 32. So 10.0.0.32 is my next network. 10.0.0.32. 32 is 64. 64 plus 32 is 96. 96 plus 32 is 128. 128 plus 32 is 160. 160, 32 is 192. And then 224. So these are the different network ID. So first IP is 10.0.0.1. Last IP is 10.0.0.30. and broadcast ID is 10.0.0.31. So in one network, you have valid host 30. Similarly, for 32, 10.0.0.33, 62 and 10.0.0.63. Like I have not written 10, 65, 65 to 94 and 95. 97, you have to start like 97 to 126 and 10.0.0.127 is my broadcast ID. Like same as you have to solve like this. Now we have to go with B and A class, like how to solve B and A class, because in that hosts are different. So the homework for you is /28, /29 and /30. You have to solve in your homework. I think it is easy for you. Why I told you about /30? Because /31 is not usable. Why? I will show you. Wait, so /28, 29 and 30 is your homework. I'm going to show you about /31 that is not able to solve. Now 31 means 31 ones. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 24, 5, 6, 7, 8, 9, 30, 31, 32. Now 31 bits are on. It means 255, 255, 255, 254 will be the value. Okay. What will be the magic value? 254. What will be the block size? 256 minus 254. What will be the number of networks? Now, how many bits are on? 7. So 2 raised to power 7 is equal to 128. Host bits are 2 raised to power 1 because only 1 0 is there, 2. So if our block size is only 2, our block size is only 2. So my first network is 10.0.0.0. My next network is 10.0.0.2. My third network is 10.0.0.4. 10.0.0.6. Like this, we have to solve 128. So my first IP and last IP is not there. Only broadcast ID will be there. 10.0.0.1. After this, 10.0.0.3. Understand the concept? Now 0 and 1, my 2 IPs are done. Host done. I don't have any valid IP to use. If I don't have any valid IPs, so it means you are not able to solve /31. Understand? Now, did you understand the concept?
Yes, so yes.
That's good. Okay, move on to B class, for example. Now this is classless, so you don't have to discuss about like B or A. But for example, you are solving /16. I'm taking just an example of 16. So in 16, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. The rest all are zeros. So what will be the subnet mask? 255, 25500. Okay. What will be the magic value? 0, because I told you 8, 16 and 24 are the fixed subnet mask. What will be the block size? The formula remains same. Block size is 256. So how many number of networks are there? Any idea? 2 raised to power in 16. N value is remains 0 because 16 is fixed length. So one network will be there. But host, how many hosts are there? Now 16 are the fixed bit. So if zeros are 16, then you have to write here 2 raised to power 16, like in B class 65536. IP address can be used in this subnet mask. So network ID, first IP, last IP, broadcast ID. So how to solve this? Because we can easily like write up to 255. Now how to write up to 65536? This is the option. Like how to do these things, because this is the important part. So let's check. Network ID is 172.16.00. First IP is 172.16.0.1. Now these are the fixed things, but these are the variable. So last IP 172.16, 255 to 54, and broadcast ID is 255 to 55. Because only fixed bits are 172.16. Now up to 002 255 they can be good. Understand? Now, for example, now your company says you solve 17. Now one bit is on. If one bit is on, then 255, 128, 0 will be there. Like in C class, the change was like there. In B class, change like is there. So 255, 128, 0, magic value is 128. Block size minus 128 is equal to 128. Now, how many bits we have done on? 1. Because 16 is fixed, we have on 1 bit, so 2 raised to power 2. 2 raised to power, sorry, 1 is equal to 2. How many zeros are there? 7 plus 8, 15. So 2 raised to power 15 is 32768, like 32,768. Now, how to divide 32,000 pieces? Same as like this. You can check. No. My first network ID is 172.16.00. Now my block size, only 1 bit is used. My next network will be 172.16.128.0. Like in C class, we have changed in 4th octet. In B class, we have changed in 3rd octet. Right, good. So my first IP is this. Similarly, my first IP is this. 128.1. These are my last IP. Similarly, my last IP into this 172.16. Now 128 is there. So 127.254, 172.16, 127.255. Because after this IP, my 128 will be there. Because when we are writing like this, like 172.16, 127 is equal to 250. After that, 251, 252, okay, 253, 254, 255. After this, we are not writing like this. We have to write 0 here. And after that, 128 will be there. So you can divide it like this. So easily you can solve like 17, 18, you can solve 18. Okay, when you will solve 18 there, then definitely 0, 64, 128 and 192 will be there. When you solve 19, then 32 will be the block size. When you solve 20, then 16 is the block size. Okay, I'm going to solve slash 23. Slash 23. Now, what is the meaning of slash 23? 1, 2, 3, 4, 5, 6, 7. 16, 16, 16, 17, 18, 19, 20, 21, 22, 23, 0. Now, this thing cannot be solved in 24. We have to solve it with slash 16. So, after solving this, this will be your subnet mask. Magic value will be 254. Block size will be 254. 2. Number of networks 2 raised to power 7, because 16 is the fixed bit, 7 bit we have done on. So 2 raised to power 7 is equal to 128 networks. How many hosts will be there? 2 raised to power 9, because 1 0 is there, 8 0 is there. So in one network, your hosts are 512. Yeah, that's good. So if you are solved like this now, what is your block size? 2. So 172, 16, 2.0, 172, 16, 4.0, good. 6.0. Like you have to add 2 into third octet. So what will be my first IP? Your first IP is 172.16, 0.1. Last IP is 172.16, 1.254, 1.255, because after 1.255, 2.0 will be there. And similarly in another network, 172.16, 2.1, 172.16, 3.254, 172.16, 3.255, because after 3.255, 4.0. Now, can it be 512? How to like check this? Because you can easily know 172. Yes. Or like by mistake, it is 254. Okay. So, for example, you are starting from 172.16, 0.0. This is your first IP. 172.160.1. This is your second IP. 172.16, 0.2. This is your third IP. 172.16, 0.255. It is your 256th IP. I'm just like rearranging this, solving this. 172.16, 1.0 is your 257 IP. 172.16, 1.1, 258 IP. So 172.16, 1.255 is your 512 IP. Understand the concept? So like for /23, you can solve like this. This is the example for B class. Now, for example, you want to solve for A class, like /10. Now, for /10 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. Okay. 255.192.00. Now host values are great here. Okay, zeros. So magic value is equal to 192. Block size is equal to 256 minus 192 is equal to 64. Number of network is equal to 2 raised to power 2, because after 8 we have add only 2 bits. Understand? 2 raised to power 2 is equal to 4. Networks are 4 only. Host 16, 17, 18, 19, 20, 21, 22. 2 raised to power 22 hosts are there. 2 raised to power 22 means 2 raised to power 22 means like we have to multiply like 64 multiply 2 raised to power 6. How? What is the value of 2 raised to power 6? 64. It is like 41 lakhs 94. 41 lakhs 94, like I have done with calculator. 304. These are the IP that can be used in /10. 41 lakhs. If you are using 9 there, then something 80 lakhs. If you are using 8 there, then it is 16 million. So how to solve it? 1 network, 2 network, 3 network, 4 network. Okay. Now 16 million is divided into 4 parts. Okay. 10,000. What is the block size? 64. 10.6400. Now value change in second octet. 10.12800. 10.19200. Understand? There you understand the concept?
Yes, sir.
Yes, that's good. Now same as like A class, B class and C class, you can solve this. But okay, not like you have to solve A and B. Tomorrow you have to just solve 28, 29 and 30 for your homework. Okay. So easily you will understand in our next practicals like how to solve this.
So which class, sir? Which class? A, B, C?
Anyone. If you are solving like A, B, C, now according to classless value, they can be solved with only in like /24. According to C class, they can be solved.
Okay.
One thing I want to explain. In A class, minimum value is /8, but maximum they can go with /30. Understand? But in B class, minimum value is 16, maximum they can go with /30. Okay. But in C class, they have to start with only 24. They can end with 30. Like A class can be go from 8 to 30. B class can be go from 16 to 30 and C class from 24 to 30. As I have done in practical /31 and 32 is not possible. Okay. So in our next video, we are going to discuss about basic commands of router like show, run, show history. What are the things? What is your Cisco packet tracer? Okay. How to work on your simulator tracer? What are the basic commands? Okay. Like how to make a design on Cisco packet tracer. And when will you come in lab, then we can discuss on original devices also. But you have to start with Cisco packet tracer. So tomorrow we are going to work on simulator because your theoretical part, LAN, WAN, subnetting devices are already completed. Okay. So thank you so much for today.